Okay, so this is Year 11 motion. Speed how fast an object moves in a linear directions are always in one direction. It doesn't matter which way you're going, it's always going to be just the magnitude that you're looking at. So, definition, probably I prefer this sort of part here as a definition. It's much better. So essentially it's just a distance travelled in the unit of time. Per unit of time, sorry, is probably a better word. Per, which always means divide. So formula, V equals D over T, and the unit is meters per second, or ms to the negative 1. Remember, this part here comes from the fact that this is m1 to the power divided by s to the power of s to the power of 1. When you move that s to the top line, then the power will become a negative. And so you can write it either way, it's up to you. If the speed of an object is not changing, the speed is described as uniform or constant. A person standing still on a moving escalator, cans of fruit on a conveyor belt, etc. All to do with these words here, uniform or constant. Car travelling at a constant speed. So a traffic officer finds that the vehicle takes 7.5 seconds, so you've got a time there, to travel 225 metres, so that's some sort of distance. Find the speed of the car. So V equals D over T, so it's just 225 divided by 7.5. The car continues to travel at this speed for another 20 seconds. What's the distance it travels? So it's travelling at 30 metres per second. That was the answer for the last one. Okay, remember you could write it like this if you wanted to. So we got, this time we're looking for D equals V times T. So we have, I don't like these triangles, but I'll put it here. V equals D over T. You could look at it just like this and go, this is my formula, here's my triangle. Okay, works like that. So D equals V times T. Putting it in, you're going to have 30 times 20. And make sure you put in the unit, meters. The speed does not remain constant during the whole journey. Then we talk about the average speed. So this is actually what we have most of the time. Because what is instantaneous speed? It is a speed at that instant, no measuring over no time. So you can't really get that. So if we're measuring over a time, so let's say you've got a car travelling down a road, okay, and you're measuring how far it goes from there to there. Well, it could be going 20 meters per second there, it could be going 15 meters per second there, it could be going 25 meters per second there, and on average is what we're looking at normally. In other words, it could be going 21.2 meters per second on average. So if you're looking from there to there, you still can have changes in speed. So if you had something that was 0.001 seconds, you could still get a change in speed between the measurement of distance and distance. So at all times we really look at the average speed. So a car drives 3 kilometers east for 5 minutes, then travels 4 kilometers south for 8, and finally 3 kilometers west for 2 minutes. Okay, so calculate the average speed of the car. Well, what you want really is the total distance over the total time. So what's the total distance? Well, it's 3 plus 4 plus 3. Okay, so that's 10 kilometers. Should make this into meters. Divided by the total time. Okay, so it's 5, 6, 7, 15 minutes. Okay, and should build that into seconds. Okay, so 900 seconds. Okay, and then you work it out. Don't forget the unit. Now velocity is the same as sort of speed, except for this time direction is important. So if you were driving your car along and you came around a corner, okay, so this is your car, you could have your speedo being fixed at 50 all the time. Doesn't change. Even though you're around the corner, squealing a bit, it still says 50. So that tells me that you're going at this constant speed. But because we are changing direction, then this thing called velocity changes, because velocity depends on direction. And we know that there is a change in velocity because you actually need a force, and we'll look at that later in another topic. How does the calculation change? For this year, not really much different. You've got a distance, or actually in AS, we'll actually make it an S for displacement. So it's actually going to be V equals displacement over time. So it's 2000 divided by 100. Okay. And when you do your thing, you should say meters per second north. Okay, there must be a direction. So when an object changes its velocity, it speeds up, slows down, is said to accelerate. Deceleration is negative acceleration. Acceleration is the rate at which an object changes its velocity. Acceleration is calculated from the change of velocity and the time taken for the change of velocity. So important thing here is because it's a change in velocity, then if you just turn a corner, keeping the same speed, you will actually accelerate. Okay. What's the formula for acceleration? Well, acceleration is change in velocity divided by time taken for that change. So the actual formula then is going to be acceleration equals change in v over t. Unit m divided by second squared, or ms to the negative 2. What's that symbol? Well, that's delta, and that means change. Okay, v, velocity, t, time. Example, car traveling at 5 meters per second speeds up to 30 meters per second, so that should be your superscripts, in a time of 10 seconds. So v, change in v in this case is equal to 30 minus 5, so it's going to be final minus initial, and so that equals 25 meters per second. That's your change in velocity, so acceleration equals change in velocity over time, so it's 25 divided by 10, blah blah blah, ms to the negative 2. Car slows down from 30 to 10 in 5 seconds, calculates deceleration. So remember, acceleration equals change of velocity over time. Change of velocity is final minus initial. So final velocity was 10, initial was 30, divided by the time of 5. So we've now got negative 20 divided by 5. So that will equal something negative, number, m over s squared.